Hi, I'm Joe Leonard of Go NMF. I'm here with my brother Charles, the creator of the product No More Friction, or NMF.
Hello.
In case you're wondering, Charles and I are not identical twins. He's the brains here. I just say what he tells me to. And in a moment, he's going to give you a very detailed explanation of how NMF works. I'd like you to know that whether you own one vehicle or a fleet, NMF will save you money, it will improve the performance of your vehicles, and make them last longer. So I'll now turn it over to Charles, who will give you a detailed explanation.
Hi, I am here today introducing you to the NMF Ionic Friction Reducer Metal Conditioner product. And we are here to talk about the benefits of reducing friction. Part of understanding the benefits of reducing friction would be to first understand exactly how it is that friction is adversely affecting your equipment and your bottom line. I'll set this down. When two things are rubbing on each other, the first thing that happens is they begin to develop an electrically attractive bonding relationship. The more that the friction is taking place, the stronger that bond becomes. In engines, the bonding represents attractiveness of all the parts and also all of the wear particles that are floating in the oil. So when a piston is firing in a diesel engine or even in a gasoline engine, the attractiveness, the frictional bond, causes the gases from the exhaust to attract together to become abrasive clusters. Those clusters are attracted because of the frictional field that's happening in the equipment, are attracted to be scrubbing and rubbing on the parts all the time. Now, friction, as it affects a vehicle, creates other side effects that are much bigger than the friction itself, with the friction just being the resistance to the motion that is happening as being caused by the bond. In an engine, you have a cylinder with a piston that is supposed to be going perfectly up and down in the cylinder. But frictional activities are causing the whole engine to be vibrating and rattling around. So you actually end up with your piston going up and down in a cylinder that is actually vibrating and rattling around. So this vibration causes the rings to allow blow-by gases to leak down and put fuel into your oil, causing your oil to become much thinner than it would have been, and also causing abrasive hydrocarbon gases to wash down, making your oil darker all the time. Now here I have a bicycle wheel. This bicycle wheel is for representing the way your harmonic balancer and your flywheel are affecting your engine. In other words, when you see a truck engine shaking, it is not just the pistons going up and down that are causing the shaking. It is gyroscopic forces that are coming from your harmonic balancer and also the flywheel of the engine. Friction is a result of electrical bonding, and in your bearings you have bonding that is pulsating as the crankshaft moves in the bearings. So the pulses that happen from the electrically attracting relationship between the bearings and the crank is creating a small vibration in your crank. Now, this is a little different, this demonstration I'm going to show you is a little different than a harmonic balancer on a truck, because the harmonic balancer on the truck would be fused directly to the shaft. So like here where the vice grips are on a bearing and they can rotate, I'm just going to only be able to show you the gyroscopic force as it happens here. But what you have to think about when you think about your trucks is that the gyroscopic force is rotating directly connected to the crankshaft, so any input from this harmonic balancer will become a rotational force back into the engine. Now what happens with a gyroscope is that when you put an input into a gyroscope, there will be a resistance that comes from a 90-degree or a right angle back at the shaft. So when the shaft is turning, and on your truck you have thousands of pounds of centrifugal force, the input is going to become a circular whiplash. Now, I'm just going to spin this without, if I can do this without knocking my lamp or anything over. I just want you to see how the gyroscope works, because this is very important to the life expectancy of your trucks. So when I have this twirling here, if I put any input, you can see how it shakes. So what happens is when a vibration is fed in, like this is a vibration, is fed into the harmonic balancer, it becomes amplified force. So when a harmonic oscillation is traveling along your crankshaft, the harmonic oscillation becomes a whiplash back into the engine. And it travels like that all the way to the other side, where it then goes into the flywheel. The flywheel responds to that. So these two flywheels, the balancer and the flywheel, are playing tennis back and forth with layers upon layers of these vibrations that are called harmonic oscillations. And what this does is this causes where in your blueprint, if you were to read the blueprint for your engine, it would say the forces in your bearings are in a perfect circle. But what is actually happening is a whiplash effect is happening, and the forces are rattling around. It is not, it's orbital motion. It is not perfectly circular. So this is wasting your fuel, but it is also creating thousands of pounds of peening and banging on your bearings. So when your engine is running, the shaft is peening away in the bearings, which is causing enlargement of the bearings. And the more friction there is, the hotter the shaft becomes, which makes the shaft expand tighter in the bearing. When you have a tight shaft in a bearing, you have less room for abrasive particles to move through the bearing without doing damage. And these particles are also attracted to stay in the bearing because that's where the frictional activity is. So when you have your, I'm going to set this down, when you have your piston going up and down, the ring is making voltage with the cylinder wall. This voltage of the ring and cylinder wall is charging the exhaust gases as they wash past the ring. So you have individual molecules of hydrocarbon gases, and when they wash past the ring is making a field with the cylinder wall that charges these gases to become enlarged. So one of the biggest effects that friction has on your truck or gearbox of your truck is that all the wear particles that are in your oil are becoming charged by the friction to cling together, so they make clusters that cause bigger scores that make new particles that are larger than any of the particles would have been had they not been attracted to each other. So what I have here is a test that is going to be able to make it so you can understand what the frictional relationship is as it naturally occurs, and then you'll be able to see what happens when we use the NMF molecule to reverse the relationship from a frictional relationship into a non-frictional relationship. So to be able to do this test, I'm going to need to make a few parts. To make the parts, I have a 1/4-inch drill bit, a 1/4-inch drill bit. I have 2 1/4-inch rods that have been cut with bolt cutters. I'm going to put a new end on each of these rods that is going to be an abrasive end on purpose for causing frictional damage. This test is a test that is not supposed to work. It is a test that is supposed to create wear, so we can see how wear naturally occurs, and then we can see how the NMF molecule works to change the relationship. So I'm going to turn on this grinder wheel here, and I'm going to get a pair of safety glasses. Now, anytime you are watching your truck, if you see that your truck is vibrating, just think about how much your engine weighs, how much your truck weighs, and then you can think about how much force it is actually taking to shake your engine back and forth with that vibration. And that force that is happening from that vibration, that force is happening to all your parts that are moving in the engine. Now I'm going to drill a hole here. These right here for now. I'm going to drill a couple of holes. We're going to be able to use this as a way that we can really see what happens when friction is taking place, as far as what the actual frictional relationship is. Now, as soon as I start to do this with the drill bit, I am making a frictional relationship between this drill bit and this bar of steel. Now, this is not the demonstration, but this is a good way in a second for you to be able to see what happens when friction is taking place, because friction is causing all of the wear material that's taking place to want to be in the frictional zone, in the friction area. Like as an example, when your truck is going up a mountain, your gears are becoming a magnet. That causes the wear particles that are in your gear oil to want to be riding on your gears. Like here, we're not really being able to see too well, I guess. Kind of see if you look here, see the metals are clinging to the end of the drill bit. This attraction here is the same attraction that is happening in your engine or your gearbox. So when your parts are going around, or your gears are going around, these particles are wanting to ride on the parts. On gears, it causes dents that make the gears have more abrasiveness, which causes even more friction. And when gears are going around, the tighter they get, the hotter they become. And the hotter they become, the tighter they get. So when your truck is going up a mountain, your gears are becoming charged to bond with each other, which makes them swell tighter, which makes them hotter and tighter, and then they will actually stay tight like that. After you have climbed over the mountain, now you're going down the road, your gears are still being tight because they were so charged up to swell as they climbed that it takes a while for that to dissipate and for the gears to shrink back down. So these are some of the ways that friction is affecting your equipment. When friction causes vibrations in your equipment, these vibrations lead to metal fatigue of your different parts. They lead to peening and damaging of your bearings. They lead to fatigue of wiring and electronic components. But when you hear squeaks happening in your cab, that's actually the sound of your dashboard, different components vibrating, and it's the sound of your wiring and everything rubbing. Wires will rub back and forth in there, and one day your truck is on fire because wires were vibrating from friction until the insulation went away, and next thing you know, you're having a truck fire and your truck is burning down when it was really just something friction was causing, and you could have used NMF and you wouldn't have had the friction, it wouldn't have been burning down. So, can you see with your one camera right here perfectly where I have drilled a hole?
Yes.
Okay, so what we're doing, we're going to do a test that is like whenever an Indian would start a fire by spinning a stick into a hole. I have created these rough ends. I'm going to try to hold them where you can see. I put grinder marks. Can you see the marks? The rough ends. Are you able to see them? Kind of the scratches.
Camera's having a hard time focusing. Yes, I can.
Okay, so what we have done is I have made these rough ends, and now I'm going to show you how these pins fit in the hole. Now this one, that pin has a burr on it. I'm going to knock the burr off real quick. We need to have them fitting in a hole. If it won't fit in a hole, the NMF is not going to make it go in there just because it doesn't fit. Okay, I think we're going around the hole there pretty good. Now, I'm hoping that the camera is going to be able to see the actual wear particles, because the wear particles are going to show the electric field that is happening from the friction. When two things rub on each other, the charge that is created is causing an attractiveness of any wear that happens during that time. So here we are going to do a method like starting a fire with a stick in a tight hole. And the first thing that's going to happen when we run this pin into the hole is that the pin and the hole are going to charge to bond. Now, a lot of times folks will ask me if the NMF product is actually an oil stabilizer product. And I'm doing a demonstration here with an oil stabilizer. This is a popular one that comes in a red, white, and blue bottle. And this test is not to knock the oil stabilizer product, it's just to show you what the difference is between stabilizing your oil and actually reducing friction. So I'm going to put some of the oil stabilizer type product in here. Now this is the kind of stabilizer that is for stabilizing your oil's viscosity. If friction and heat were thinning out your oil, the idea with this kind of thing is that this would make your oil thicker and make your viscosity be more stable. Here, if you look in the light, you'll be able to see that the oil stabilizer is attracted to itself, or to explain what I mean when I say it's attracted to itself, you can see that it is making threads that are like a yo-yo. They'll spring back. That's because this is an adhesive type oil. It's made to cling to things. And friction is caused by the adhesion of surfaces to each other. And the more they adhere, or the more adhesive they are, the more the frictional relationship is actually occurring. So I want you to look with the camera that is facing down at the pin, and everybody who's watching, really take a close look here, because I'm going to create some wear now. We're going to run the pin into the hole. Now the first thing, like I said, what's happening when we walk this in is this pin is right now, I'm only pushing a little pressure with my fingers right now, I haven't really started pushing much, but this pin and this hole are charging opposite to each other. Now, because I just drilled this hole a minute ago with a drill bit, there is some really fine metal dust in the hole from before we start, because the drill made the hole into a magnet and there's dust in there from the drill bit. So what I'm going to show you here is the snowball effect that happens, and this is the same snowball effect that is happening in your engines and gearboxes, is that particles are always attracting to each other to make a larger and larger size particle. So I'm going to now start to put some pressure here, and I'm hoping that the drill, if you look in the light, this is locked up here now, okay? And I want to try to do this again because I want to make more metal, but this is locked up tight, okay? Now, this is actually what they call, and I didn't do it long enough for it to be a true frictional weld yet, but when two materials rub together like this, the attractive bond can become a permanent bond. When they make a shaft for a turbocharger on a truck, they take the two sides and they spin them together the same way, and when they finally have a frictional seize-up like that, now you have a permanently put together turbocharger shaft. It's permanently put together unless something happens. So now, you can see how this is locking up. And if we look in the light, there's a little bit of metal, and you can see the size of the metal wear. Are you able to see it at all? The particles. They're just starting. I'm going to make some more. Now I was pulling pretty good with my hand there, but see, because friction is an electrical activity, the more friction there is, the stronger the bond becomes. So a moment ago, I was having to use my whole hand. Now that these pieces are really charged up to be bonding with each other, I should not have to use very much pressure anymore now to get it to wear out. So I'm just going to only use my one finger. And now you can see when I use only one finger that it seized up, it has seized here, and there is a corona of wear material around the pin. The purpose of this test is really for you to see these things and understand what this frictional relationship is. So I'm going to do this again because I really want you to be able to see the metal on these cameras. I can see the metal really good from where I am at. Now this time I'm going to try not to seize it up quite so fast because I want you to see the friction. Now listen to the sound. I'm going to be quiet. Listen to the sound. Hear the grinding? And that's a lockup. And we're making a lot of metal wear here. And I really want to make some metal because I want you to be able to see that once we have metal that is forming from friction, there will be no space in between the metal particles. The particles are going to be completely locked up with each other. So, if we can come in the light, let me know if you can see.
I can see all the metal particulates.
Can you see that they're pretty much stuck together like a slurry? They're bonded. They're not having any space in between them. This is what's happening in your trucks, in your engines, in your gearboxes, transmissions, hubs, anywhere that you have friction activity, frictional connectivity happening with your parts. Everything is bonding like this. And that's why this won't go around. Now they would like you to think that when you start up a hill, that hill has to bog you down and has to wear out your parts in the way that you always notice. They would want you to think that the work is directly relative to how fast your truck is going to slow down. But I'm going to show you now that it doesn't have to be that way because friction is a type of relationship. You can have a good relationship with your dispatcher and it's a non-frictional relationship. And then you can have a bad relationship with your dispatcher and it's a frictional relationship. So I'm going to show you how to defrictionize the situation with the NMF. So I'm going to explain what the NMF is doing to help you to understand this. The NMF is not slipperiness. It is not a motor coating substance, and it is not an adhesiveness, and it is not a friction fighter. The NMF is not fighting with friction. The NMF is actually neutralizing the cause of the frictional relationship, so there's no fight happening. The NMF is an electrically excitable molecule that when the NMF comes into the frictional relationship that is taking place, the NMF becomes excited by that relationship, which causes the NMF to become a broadcaster, a generator of free electrons. So here I'm going to put a little bit of NMF right in the same hole where we were having the frictional relationship. And now I'm hoping you're going to be able to see what is going to happen. Because when you treat your engine, or you treat your gearbox, you treat your hubs or rear end, you're not just treating the parts. You are treating all of the particles of wear material to no longer be attracted to be chewing on and wearing out and eating up your parts. When you drain your oil or drain a fluid and you see the metal in there, those particles that are going away forever used to belong to you. They used to be your engine. That's your engine or gearbox. So I'm going to show you what happens now. Right now we have a cluster of wear material attracted right to the hole. It's really thick all together. If you look, it's very hard to see any individual sparkles because the sparkles are all laying on each other, attracted like a magnet. So I want you to try to get my finger. Tell me if you can see my finger on the end of the handle. Okay. I want you to watch my finger because my finger is going to be a vibration sensor. It's going to show the vibration because the NMF effect is not instantaneous. It's going to take it a few seconds to do it. So when I first start to walk this pin down into the hole, the pin in the hole and all the metal in there is all going to be attracted at having friction. Momentarily, the NMF molecule is going to broadcast electrons that are going to charge that pin, that hole, and all that ground up metal all the same. And we're going to be able to see as the frictional relationship in the bouncing of my finger, see how my finger's bouncing? See the vibration? The NMF is beginning to give off electrons in the hole. Now, I want you to look now, because now, if you look, the particles of wear material can now be seen free and flowingly floating around the pin. So they are floating around and away from the pin, and if you look, if you can see with the camera, these particles are now individual particles of wear. Now, this is very important for the life of your equipment because what happens with your oil filter is particles of wear material are always on the way to your oil filter. From the time that they're born, eventually they're headed to your filter where they get taken out of your oil. But what happens is before a particle can make it into your oil filter, that particle has scrubbed in a tight place, made another flake, and multiplied itself before it gets to your filter. So your filter is always doing an ongoing job of trying to catch up on these wear particles, where when we defrictionize it, these particles are not making friction anymore. Let me see, here I have a thermometer. Let's take a look. Now, I will say this, we have a very hot floodlight back here, and it's actually making the bar of steel and everything here kind of warm just from the floodlight. But I want you to tell me if you can see this temperature gun here. Are you able to see, we're at like 128 degrees or 129.
A little more.
Are you able to see it? You got it? Okay, we're at 120 something degrees. Now, when I do this very same demonstration all the time without that really bright floodlight aiming at my bar of steel, it usually is doing this demonstration at 110 degrees or less. So we had more than 10 degrees of temperature that was additional to this demonstration from this hot light here. But now, if you notice, that the wear particles are all floating around out here at the end, on the outside. Now, what I want to show you, if you can take a look now, you'll be able to see what I mean, that the particles have floated away from the hole, and they're free, solitary, individual particles here now. Now, what happens when you do this to your engine is the particles are the same as the engine, so the particles are not scrubbing or scratching anymore. So the filter, for the first time ever since you have had your truck, the filter is able to catch up. In other words, the particles are multiplying and the filter takes them away faster than they're being created. And this causes your oil to be much better for your truck, but it also causes an increase in the lifespan, the oil drain interval. Now, I'm going to show you the same demonstration again, and we're going to use the same oil, except this time we are going to defrictionize it from the beginning. Well, I'm going to set this one right here because I want us to look at it. We're going to look at it in the end in just a second. Now, like I said before, there is some wear particles in here. They're already in there because the hole was a magnet whenever I drilled it. The difference is going to be, and I'm going to use the same oil stabilizer product. Now, you can remember when we did this with the product moments ago, that the frictional excitement was building very fast, and we weren't being able to go very long at all with, let me even get another Q-tip, we weren't being able to go very long at all without it seizing up or wearing out. So I'm going to get another little drop of this. Now watch my fingers this time. Watch my finger for vibration, and you will see that the vibration will go away pretty quickly this time. The vibration has already left, and now we don't even have any sound of any frictional activity taking place. Now, whenever you have taken away the frictional vibration, now you're not creating the wear, and this is staying very clean. If you can look down now at the hole, you'll see that this is very clean. And we will look with another one. Another Q-tip. I'm going to clean the two holes here. So, can you see the end of that?
Yes.
And here is the one that was done with the NMF from the beginning. Now, this really means something whenever it comes time to getting an oil change. Normally, whenever you drain your oil, the oil has a lot of charged particles that don't want to come out. So when you drain your oil, oil comes out. The last little bit of oil coming out is thick with abrasive grit and leaves a lot of abrasive grit in your engine. When you're using NMF, when you get an oil change, you want to go somewhere where they're going to give you the time of day for the oil to come out, because the NMF charges all the crud to go ahead and come on out, so you end up with the cleanest oil change ever. Now, whenever you have a frictional vibration in your engine, the centrifugal forces, the gyroscopic forces are shaking your truck. The NMF charges the bearings the same, the harmonic oscillations go away, and that's why when you see our videos where there's water jugs sitting on trucks, you can see what happens, that it takes away the frictional vibration. Here I have a recording that we make with a little mechanical device. This mechanical device, I call it a seismograph, but really it's a kitchen egg timer and a piece of an omelet whisk. And what I do is I have a little disc that pops on here. I clamp this thing to your step of your truck. So this is clamped to the step of your truck. There's a pen. I use a different kind of pen. I use a Pilot Razor Point pen, but there's a pen that is attached here like this. We wind up the disc, so when the pen is on there and this is clamped to the step, the pen is bouncing around and dancing with the frictional vibrations that are coming from those harmonic oscillations as they're being responded to by the balancer and the flywheel. These vibrations are creating a recording on the little disc. So you can see how the pen is vibrating here, and because the disc is rotating with the timer, I leave it walk along for a little while so you can see how it is. Now, are you able to see here where I begin to add the product in? Here's where I add the NMF. As soon as I add the NMF, the pen's behavior starts to change, and that's because the harmonic oscillations that are being received by the balancer and the flywheel are no longer being produced. It takes a while for these vibrations to quit whiplashing back and forth. So as it goes along, here now, 25 minutes later, you can see the way the truck is running when the harmonic oscillations have went away. This is bearings that are operating without banging around. So the size of the bearing is no longer swelling up. It isn't banging around. It actually causes a better wear pattern to happen in bearings whenever you can have them to operate without the banging around. So when you think about what the benefit is in reducing friction in a truck, of course, all of these efficiencies will lead to fuel economy. But to me, because I've had so many drivers tell me, thanks for the free truck, because their truck is over 2 million miles and they feel like they got another truck just for the benefit that they got from using the NMF in the truck, I feel like the fuel efficiency is a benefit. The savings on oil you should be able to get oil samples that are better at 40,000 miles than you used to get at 10 or 12,000 miles if you just defrictionize your truck and change your filter every 15,000 miles. So in other words, if you change your filter every 15,000 miles and add makeup oil, and if you have to add NMF at a rate of 1 ounce per quart to your makeup oil, you will be able to sample that oil at 40,000 miles and have a better oil than you used to have at 10 or 12,000 miles. So because 1 bottle of NMF is going to do your oil, a gallon will do your oil 3 times, then you should be able to save close to $700 on oil with 1 gallon of NMF. There is a nice chart on the back of the bottle that completely explains how the NMF is used everywhere. Now let's take a look at the parts that we did wear out over here. And let's see how they are looking. So, if you can look in the light, this is the first one. This is the first one that I wore out, and you can see there's a whole bunch of metal here. Just tons of metal. Do you see it?
Yes.
Now, I don't know if, maybe if I poke this up through the hole, it'll give you a better angle. Is that a better angle? To see the end of that pin?
Yes.
Can you see it? It's all circles and wore out? Is it showing up on the camera?
Yes.
Okay. Now, I'm going to clean this one off. Can you see where I clean this one off? That there's not the big thick cloud of wear material?
Yes.
Okay. Now let's look up through, I'll put it up through the hole again and see if that helps. You can see that the scratches are still the same. They're not circular. They're still the same.
Yes.
That concludes the presentation of the NMF product and how it pertains to the lifespan and efficiency of your vehicles and your bottom line.